All right, in this lesson, we're going to be talking about scatterplots and correlation coefficient. By the end of this lesson, you should be able to graph scatterplots with and without technology. You should be able to identify the correlation and the correlation coefficient. And then you should also be able to compare and contrast association versus causation. When we hear the word scatter, we tend to think of words such as distribute or to take flight, to disperse, to free, to fling out, to spread out. When we're making a scatter plot, we're thinking of this word scatter, and what it is we're taking all of this data that has been spread out, that's been dispersed, that's been flung out, and we're collecting it, and we're putting it together, we're putting it into a graph so that we can talk about this type of relationship that the type of relationship that it has. This relationship is called a correlation. And correlations are a little bit different from direct variation or causation. Because correlations just talk about the type of relationship that we've observed. So we might see that the more that I study, the higher the grades I get. Or the more that I practice baseball, the better I play. This is a relationship, and we see that there's a positive relationship here. There's a positive correlation. But what we can't say is that by studying, I got a higher grade. Or by practicing baseball, I play better. Because there are other variables, other things that could affect that, right? Like I could study for 5 hours and be terrible at history and still make an F. Or I could study for 5 hours but be awesome at math and make an A, right? And that same person that studied 5 hours could have just studied 1 hour and still made that same grade. So we can't say that there's a causation there. We can't say that by studying it's going to cause you to have higher grades. But what we can say is that there's a relationship between the number of hours that you study and the grade that you get. And the relationship that we've observed is that it's a positive relationship. So unless we can rule out other variables, other lurking or hiding variables, we can't say that something has causation. We can just say that it has a correlation there. And this is important for you to know because you're going to see a lot of advertisements, either whether it be political campaigns or advertisements for certain medicines or products that say by taking this it's going to cause this to happen. It's important for you to kind of understand this idea of causation versus correlation. So we're gonna dive into that just a little bit further in just a second. Let's start off by talking about scatterplots though. So what a scatterplot does is it takes two sets of data that we wanted to observe and it plots it as ordered pairs on a graph. And we use this graph to determine the type of relationship. Does it have a strong relationship? Does it have a weak relationship? Is the relationship positive? Is the relationship negative? Or is there even a relationship to begin with? And so let's look at these three types of relationships that we're most commonly going to see. We're either going to see a positive correlation, which means that as the variable on x increases, the variable for the y increases. So it's positive, going up. We'll see our points kind of trending upward, like we do in our example here. It could be that as x increases, y decreases. This would be a negative correlation, and so this would look something like this right here. For example, how long a candle has burned and how tall it is. That would be decreasing. The time would be the x, the height of the candle would be the y. Or no correlation, which would look like a bunch of points kind of scattered about with no organization or trend whatsoever. They're just kind of all over the place. We can't tell if it's going up, we can't tell if it's going down. There's really no relationship there. And so this is what no correlation would look like. And so when we're looking at these types of correlations, we're really looking at this trend. The other thing that we want to talk about though, besides if it's positive or negative or no correlation, is how strong that relationship is, how strong that correlation is. And there's this thing called the correlation coefficient, and the variable that we use to represent correlation coefficients is called an R, or it's called R. And what this tells us is it tells us how weak or strong our correlation is. It tells us how close these points are to our line of best fit. If you recall from previous studies of scatterplots, this line of best fit is the line that goes to the central part of your data. And so what your correlation coefficient does is it tells you how close those points are to the center part of your data. And your correlation coefficient is going to be a decimal between -1 and 1. If it's -1, it's perfectly negative. If it's +1, it's perfectly positive. And in those two cases, we could say that it has causation. Every other one, though, any other decimal number that you have there is either going to tell you that it's really strong or really weak, depending on how close it is to 1 and -1, or how close it is to 0. Just want to revisit this idea of association versus causation one last time. Again, something that has an association or a correlation just means that there's a relationship and we see a trend. How strong that trend is or how weak that trend is, we want to make sure that we are looking at that closely so that we're not being misled. Causation, on the other hand, is saying that because this thing happened, it caused something else to happen. So for example, because I cut the paper with scissors, now the paper is in two pieces. So there is a causation there. Because I cut the paper, now it's in two pieces. Versus the grade that we earned and the hours that you studied, where we just see a relationship. Again, the big thing to look out for here is this idea of lurking variables. Is there something else that could have had a significant effect on the two variables that could have skewed or changed the relationship? Okay, let's look at a couple of examples real quick. So we want to determine if the graph shows a positive, negative, or no correlation. Our first graph here happens to show a negative correlation. Those points are going down. As the x increases, the y is decreasing. We look at the second one, and it's a positive correlation. Again, as x increases, y also increases. We look at this last one. This last one has no correlation because there is no, we cannot tell if it's going up, we cannot tell if it's going down. It's just kind of all over the place. When we're looking at the graphs here, again, when we're trying to tell if it's strong, if it's weak, if there's no correlation, a lot of times we're going to be looking at real-world problems. So in this particular graph, we see this graph shows the fat grams and the calories for the selected choices at a fast food restaurant. The graph here shows a positive correlation, and this correlation is moderate. Again, if I draw my line of best fit here, my points, they're close, so I won't say that it's weak, but they could be closer, so I can't say that it's necessarily strong. But what we can say is that as the number of fat grams increases, the number of calories increases. So we have a correlation here. We'll look at this next one. Again, this would be a negative correlation. I would say this correlation is a little bit stronger than the one that we had before, because if we look at our points, they're just a little bit closer to our line of best fit than what we had before. But this graph shows a negative correlation, and as the weight of the automobiles increases, the gas mileage also decreases. So you want to be able to describe what's happening to the graph. You don't just want to say that it's a positive correlation or a negative correlation. You want to be able to explain what's happening. So here again, as the weight increases, the gas mileage decreases. You want to be able to articulate and explain that. We're going to determine whether the following statements are causation or if they're association. So we have A, it says the number of cold days and the amount of hot chocolate sold at a ski resort. We can't say that because it's cold, more hot chocolate is, that's what caused more hot chocolate to be sold. But what we could say here is that there's a relationship between cold, snowy days and the amount of hot chocolate at a ski resort. Again, there could be other variables such as a sale, such as a holiday, that could have affected the amount of hot chocolate sales. When we look at this one, it says the number of miles driven and the amount of gas used. This would be causation. The more miles you drive, the more gas you use. So the more miles you drive, the more gas you use. So the number of miles driven, the amount of gas, that is, the more gas that is used. Looking here, it says the number of additional calories consumed and the amount of weight gained. Again, we can't necessarily say that there is causation here because there could be other factors such as being pregnant that could explain weight gain. The age of a child and his or her shoe size. Again, there is a relationship here, right? The older you get as a child, the larger your shoe size becomes. But again, we can't necessarily say that because you're this old, it caused your shoe size to get bigger. There could be other things such as hereditary and genes that could cause you to either have small or larger feet. For looking at this one, the amount of cars a salesperson sells and how much commission he makes. Car salesmen earn their money based off of the amount that they sell. So we could say here that there is causation between the number of cars that they sell and the commission that they make. Because if they sell 2 cars, they will make this much money. Okay, now we're going to look at a situation, and we're going to graph. We're going to do some things in our calculator to kind of help us to be able to do this type of question. So what we're going to do is we're going to start off in our calculator by going to New Document. And what we're looking at here is the relationship between the fish in a small pond and the number of years that those fish have been in that pond. And so when we go into our calculator, we're going in a New Document. So we're starting off in Home. So we're starting off at Home. We're going into New Document. If there's something in there, we want to clear it out. We don't want to save it. And we want to go into Add Lists and Spreadsheets. And so what we're going to do here is in Lists and Spreadsheets, we're going to go up into this column, and we're going to label it. We're going to label our table the way that it's labeled on our problem. So we're going to put in the A column, we're going to type in years, so that we know that this column represents years. In our second column, we're going to represent the population. So I'm just going to put pop for population. I don't have to type in the whole thing, but I know that now whatever values I put in for A are going to represent the number of years, and for the population for B are going to represent the population. So we're going to go back down until we're in this little area right here where we can enter our values. So in years, I'm going to put in 0, I'm going to put in 1, 2, and I'm going to do this all the way up to 8. And then I'm going to go over to population. I'm going to go back up to the top, and I'm going to type in those values. So at year 0, there were 12 fish. At year 1, there were 17. Year 3, there were 15. At year 2, I gotta go back up. Oh yeah, at year 3, there were 15. At year 2, there were 15. At year 3, there were 23. There we go. At year 4, there were 35. At year 5, there were 37. And then at year 6, there were 41. At year 7, there were 42. And at year 8, there were 47. And so now that we have these values in here, we want to construct, or we want to be able to make a scatter plot. So what we can do here is we're going to go into Document. So we're going to press Document again. Document's on the side over here. So it's highlighted. It was highlighted for me. Document's on the side over here. And so what we're going to do is we're going to scroll down and we're going to insert a new page. So the page that we're going to insert this time is a data and statistics page. And so when we insert a data and statistics page, you'll see a bunch of points that are scattered. So what we're going to do is we're going to make our scatter plot. On the x-axis, that is going to be our x variable, which in this case is years. On the y-axis, it's going to be our y variable, which is population. And what we can see is that there is a positive correlation between my points here. Okay, so we're going to hit Control. We're going to go back to our table, and now we're going to use this to get our line of best fit. So from the table, we're going to press Menu. Menu's underneath Document, currently highlighted for you. So you're going to press Menu. We're going to go into Statistics, and we're going to go to Stat Calculations. When we're in Stat Calculations, it gives us a bunch of kind of options here. We're going to select the third one, which is linear regression. This is going to give us our line of best fit. This is also going to tell us our correlation coefficient. So when we do this part, it's going to pull up this little menu button over here, and we're going to type in, off to the side, we're going to type in years. For our X, we're going to go down to the Y list, we're going to type in population. And then we're going to press OK. We're not going to type anything else. We're going to go down, we're going to press OK. And what you'll see is it gives us our line of best fit. It gives us our linear regression. It gives us our slope, which is 4.6. It gives us our B, which is 11.15. And it gives us R squared and R. Our correlation coefficient, which is what we wanted, is 0.97. And so what that tells me is that I have a very strong positive correlation between the number of fish in the pond and the number of years that the fish was added. 0.97 is really, really close to 1, so this tells me that I have a very strong positive correlation. To determine the linear regression model, to determine that linear model, we're taking the slope, which is m, so we're taking this value right here. We're taking b, which was 11.15 or 11.2, and we're writing it in slope-intercept form. So when we write in slope-intercept form, we get y equals 4.7x plus 11.2. And then what we can do from there is we can make predictions. So we can take our linear regression model and we can make predictions. So for this one, it says predict an outcome given a domain value of 15. So what we would do is we would plug in 15. We plug in 15 into our equation. So what we would have is y equals 4.7 times 15 plus 11.2. And what we would get is the y, which would be 81 fish. Now, it wouldn't be 81 exactly, but we would have to round to the reasonableness. So if it wasn't a full additional fish, then we would have to round down. When we want to predict the y, what we would do is substitute in the y value, the range value in for y, and then we would solve for x. And so now we have a multi-step equation. And so using this equation would really help us in figuring out and making predictions. So from our table, by going into menu, by going into statistics, stat calculations, and linear regression, what we get is two things. We get our correlation coefficient, which is R, so this piece right here, and that tells us how strong our correlation is. And then we get our equation. We get the slope of our equation, we get the y-intercept of our equation, and then that allows us to write our equation in to slope-intercept form, and then we can use that equation to make predictions. All right. The thing that I would like for you to consider before watching this next video is the difference between association and causation. As usual, please subscribe to the channel so that you get updates as videos are released, and thank you for watching.